All right, what's up, guys? Welcome back. We're going to look at the gravitational force effects from last week. So just a key to make sure that you got this as we went over it in class the other day. So planets closer to the star. Pre-lab questions, what I found with this one, I wanted you to think about more than one planet at the same time. So would they be moving faster or slower from planets further away? So multiple planets in there. So if you pictured like a solar system, which planets would be moving fastest? A lot of kids just interpreted this about the elliptical motion, so when it would be moving fastest as it's coming towards, not thinking about multiple planets. So that was kind of a key thing here for the first two, and then the third one was about the ellipse. So if you read these and you thought question 1 and 3 were the same, then that was our mistake in communicating those questions. So here, as you went through, we were attempting to get at this pattern that question 1 was asking about. So you don't need me to do it for you because you've got that data already. But what you would find, or what you did find, as the planet got further and further away from the sun here, is that the speed decreased as it got further away. And that's not the single planet moving further away. That's if I had, here's a planet close to the sun, here's one further away. The further away one was going slower. The problem with this is that that works if they're the same mass. So as you change the mass of the planets, like we have in real life, that complicates that a little bit more. But we want to keep it simple right now. So thinking about these as if they were the same mass. So you didn't have force vectors, but the force of gravity on the planet would always be what direction? That's going to be towards the star or whatever it's orbiting. And so you know that because that's the gravitational force keeping it in orbit. So if we have the gravitational force, which decreases as you get further away, why is it that the speed decreases? So this is what I was really curious to see how you were thinking about this. So look back at your answer and compare it with what we say here, what we talked about in class. So there'd be less force further away, which means that the planet would be going slower, because if it was faster, it would go out of orbit. All right, so it can't be going as fast as the one closer because now it's being held less force on it. So in class we used, I think, a rope or a string or something and thinking about something going around. And if I'm pulling really hard on it when it's close and it's going slow when it's further away, then that's just not going to work because so if it's closer in orbit, I'm pulling hard on it, it's got to be moving fast to stay in orbit. If it's further away and I'm pulling not as hard, the force is weaker on it. If it's still moving that same speed, it's just going to go right out of orbit. So kind of making sure that you understand that. Then we had the tides, and everybody did fine with the tides. Thinking about as we're closer to the moon and the bulge that creates with the water. So interestingly, if you picture a circle, right, like this, I have a hoop at school. It'd be perfect for this. But if I take this circle and I pull on one side of it, what that does is it takes the circle, instead of being round, it kind of squishes it. So a lot of you use that word squish in your description. But that's what causes the bulge on both sides, and then the sun interacts with that. So people did pretty good with that, so that was fine. But tides are interesting. And then here, the slingshot effect. So as we go here, I want to make sure. I think some people just maybe didn't describe this the way that I anticipated. So as we look at this, So we want to be able to select all three of these at the bottom. So here, different distances away, and then start it. And the key thing is they're all the same velocity coming in. This one that's closest gets pulled more by, I think this is Jupiter, yeah. And so the key part right here is kind of thinking about now what's happened after. So not only does it change direction, but it changes velocity as well. So the closest one changes velocity the most because it had the strongest force, no gravity on it. So that's an interesting way to speed something up in space. And then this other video talked about how when they sent the Juno spacecraft up into on its mission, and so it couldn't get out of Earth's gravitational field. I think it was the Earth or the Sun. I don't remember right now. But in order then to get it where it needed to go, they slingshotted it or used a gravity assist of the Earth, and then that gave it enough speed to get out on its mission. So it was that same concept that you're seeing right here. They just brought it around the Earth to get it going fast enough to where it needed to go. So that one was a little bit more straightforward of an assignment right there. So just make sure, let me know if you do have questions about anything on it.